In this session, let us solve a question from CSIR NET December 2024. We have a spherical cavity of volume V. It is filled with thermal radiation at a temperature T. The cavity expands adiabatically to 8 times its initial volume. So we have Vi is equal to V, Ti is equal to T, Vf is equal to final volume is 8V. If sigma is the Stefan's constant and c is the speed of light in vacuum, what is the closest value of work done in the process? So we have to find work done in the process. We know from first law of thermodynamics, delta Q is equal to delta U plus delta W. Now for adiabatic process, delta Q is 0. This implies delta U is equal to delta W is equal to minus delta U. Now delta U is nothing but UF, final energy, minus initial energy. Therefore minus of delta U will be equal to UI minus UF. Therefore we have here UI minus UF. Therefore we have to find this initial energy minus final energy. Now what is energy density in the case of a thermal radiation in spherical cavity? It is given by U is equal to AT raised to 4, where A is nothing but 4 sigma by C. Now this value of A, it is not so famous, but you can see it in Introduction to Thermal Physics by Daniel Schroeder. So we have U is equal to 4 sigma by C T raised to 4. Now U here, it is energy density. It is the energy per unit volume. So to get energy, we will multiply small u with V. Therefore we have U is equal to capital U is equal to 4 sigma by C T raised to 4 V. Ui will be equal to initial energy will be equal to 4 sigma by C Ti raised to 4 Vi. Uf will be equal to 4 sigma by C Tf raised to 4 Vf. Now Ti is T and Vi is V. Therefore we have Ui is equal to 4 sigma by C T raised to 4 V. Now Uf is equal to 4 sigma by C Tf raised to 4 Vf is given to be 8V. Now let us find Tf. We have to find the final temperature. To do that, we are given that the process is adiabatic process, and let's assume that the process is reversible. For adiabatic reversible, we have for adiabatic process delta Q is 0. This implies delta S is equal to 0 for reversible process. Now the entropy of photon gas or thermal radiation, it is nothing but S is equal to 4 by 3 AVT cube plus some constant. I hope you remember this. Now if entropy is not changing, if delta S is equal to 0, then this implies that VT cube must be constant. So for adiabatic reversible process, VT cube is constant in the case of a photon gas or thermal radiation. Therefore we can write Vi Ti cube is equal to Vf Tf cube. Now Vi is V, Ti is T, Vf is 8V, and Tf is what we have to find out. From here Tf cube is equal to 1 by 8 T cube. This implies Tf is equal to, if you take cube root on both sides, you will get 1 by 2T. Let us put it back here in this place. Then we will get Uf is equal to 4 sigma by C T by 2 the whole raised to 4 8V, which is equal to, now 2 raised to 4 is 16, 8 by 16 is 1 by 2, so we have 1 by 2 times 4 sigma by C T raised to 4B, which is nothing but 2 sigma by c t raised to 4v. Now ui is given by equation 1, uf is given by this value 2 sigma by c t raised to 4v. So let us find ui minus uf. ui minus uf is equal to the work done in the process. This is equal to, from 1 we have ui value is equal to 4 sigma by c t raised to 4v minus uf is 2 sigma by c t raised to 4v. Therefore this is coming out to be equal to 2 times sigma t raised to 4v by c. Option D is the correct answer here.